All right, Alexis, what is it you want to learn about today?
Well, multiple times you've talked about we were going to do a thing over energy, and I think it would be good to do that now.
Do that now. Okay. Uh, so, um, yeah, one of the things that I think is important because we keep talking about energy, and we talked about energy a little bit. Oh man, that's way over there. Whenever we were talking about
In Texas?
what happened in Texas. So I believe very strongly that our energy choices are sort of important for the kind of country that we want to have. And I think that we're making two really stupid choices. So one of them, uh,
Wind farms.
wind farms,
It looks
and
like a sad wind farm.
the other one is these things,
Solar panels.
solar panels. Now, actually, solar panels I think are good for certain implementations. So, for example, we have a house and a barn. Like, if we wanted to put some solar panels on it to help reduce our cost and increase our resilience. So if one of the things that would be cool is if we have this at our barn, because we have animals that we take care of, if the grid power that we have coming in goes out for some reason, then if we have batteries and a solar cell to help back up that power, that it means that it's better for our animals, right?
We can have round the clock energy.
Well,
Well, unless it's cloudy.
so the solar system would have batteries and it would charge it up. But so like we have fans and things like that running in the summer, and we have heaters and heat lamps running in the winter. And if there's a power failure from the regular power grid, if we had a solar system, in good times, it could help reduce our cost. But in bad times, that would provide a good, efficient backup for, you know, the regular grid. And so, yeah, if there's a power outage like there was this winter, then our animals would still be safe. We would have time to make other arrangements instead of them being at risk of getting too hot or too cold or something like that because the power went out.
Mm-hmm.
And I think that the solar provides a really good opportunity for that. I think, like, if you had a school or a hospital or any of these other buildings that are sort of important, and you wanted to, a lot of them, oh, that's a terrible looking hospital.
Eh,
But
best drawing you've done so far.
if you wanted to back them up, so hospitals, a lot of them have um, backup generators anyway, but if you wanted to supplement that with solar, again, it should help reduce the cost during regular times, and in an emergency, it's going to provide additional backup power. So I think solar is really good for that.
Mm-hmm.
I also think solar is good for sort of off, what you might call off the grid applications. So I know you've seen, like, around here we have these stop signs that have like the flashing lights.
Oh yeah, I've seen those.
Yeah, how are they powered?
I don't know.
Well, there's not power. If you pay attention, there's not a power line connected to them.
No, I have not seen a power line.
They have a little post up above them, and they have a little solar panel
I
on it.
think I've seen that before. I didn't know what that was though.
Yeah, so that's a really good application. So we don't have to run wires, we don't have to have a meter. We have this sign, and it flashes for additional visibility and to catch people's attention. And it doesn't have to be connected to the grid. And it has a nice solar panel. Solar panels, they last a pretty good long time. I mean, they have a service life. Eventually, they start sort of wearing out the more that they're exposed. But it's long enough that it's not terrible. So solar has some uses. Solar, I do not think should be connected to the grid for a number of reasons.
What do you mean by connected to the grid?
So the grid is like where we get our power in our house. So like the power lines that are running into the house, like just regular power.
Yep.
So that energy comes from a large energy generator, and it's called the grid because it's kind of like, if you look at the maps of it, there's all these lines sort of connecting them out. Both of these have an incredible problem if you try and connect them to the grid. One of them is that these are super low density energy sources. So one of the things that people who like these kinds of energies, they'll say that the source of it's always free. The sunlight and the wind are always free.
Well, yeah.
But they're also diffuse, which means that they're spread out. So there is some research, and it will take 100 to 200 times the amount of land area for a wind or a solar farm to generate the equivalent power of a nuclear power plant or like a gas-fired natural gas dual cycle plant.
That's a lot of land.
Yeah, so it's really spread out. The other thing is that these sources are what they call intermittent, right? And so that's something we talked about a little bit, even though as I scroll, a terrible intermittent up there. When we're talking about Texas, the wind power only works when the wind blows, right?
Yeah.
And the solar power only works when the sun shines. And so that means that there's only certain times of the year when these work really well, and there's even only certain times of the day when they work really well. So if you have a cloud move into your area, like you have an overcast day, your solar panels aren't going to produce as much. And because that is intermittent, you have to have some sort of storage solution to try and sort of solve the problem so that you have power when you need it. And we do not have a good storage solution.
We don't.
Yeah, and there is a guy. So if you like YouTube, there's a guy called Real Engineering.
Well, if you're watching this, you probably like YouTube.
Yes. And he has a video where he sort of does a breakdown on like storage problems for renewable energy.
I think I've seen some of these before.
Yeah, I share them with you.
Yeah.
And so one of the things he's talking about is that just in a state like California, which has lots of renewables, they've wasted a lot of money investing in wind and solar, and they have a lot of sunshine, so it should be good. Like they need an additional billions and billions of dollars to try and invest in storage so that their power grid will be stable. Because that's one of the things we talked about. You need to have an energy matchup so that you don't have too much electricity in the grid at one time, or you don't have too little, or you start getting blackouts or brownouts. Or
Wait, what's a brownout?
Brownouts where you just get low power, not no power. So you don't get quite enough electricity.
I think that would be more of like a gray.
Well, they call it a brownout. And then so that you don't have too much electricity where you have things like getting overloaded and catching on fire.
Well, that sounds horrible.
The current storage solutions are batteries, and the battery technology is not really good enough to operate on the grid. And there's some new solutions, but again, we're talking about billions and billions of dollars of investment just to get storage solutions.
You're gonna need some D batteries.
Yeah. One of the other ones is this thing called pumped hydro. And pumped hydro is like, it's basically like reverse hydroelectric. So when you have lots of power, you have these pumps and they're sort of reversible. And so when you have lots of excess power, so it's like it's during the sunny part of the day, and let's pretend these are hooked up to solar panels. You'll use the extra power to run pumps to pump water up into this reservoir at the top of a hill.
Is that a good idea?
Well, yeah. So basically, you're taking the excess electrical energy and you're converting it into potential energy.
Okay, that didn't sound horrible.
And then so at the end of the day, the sun goes down, people are at home, they're turning on their TV sets, you need power, your solar cells aren't working anymore. Well, then you open up the valves, and all of those pumps, when they run backwards, are now electric generators. And so now all of that potential energy is converted into kinetic energy, and you're going to harvest that kinetic energy to make electricity.
That's not a bad idea.
It's not a bad idea. The only problem is there's not very many locations where you can do that efficiently.
Wait, could you do this with wind? Like, could you find a way to reverse it, kind of like they're doing with this, but could you do that with wind?
Well, you can take wind power and you can pump the water, but like air would be a poor storage medium. One of the other solutions that has been presented, so I have no idea how to search for it. So it's like, so let's do crane energy storage system. They're doing sort of a similar thing, but they're trying to use, gravity energy storage. So that, I think, is what they're trying to do. Instead of pumping water, they're using, of course, we've got to have an advertisement. They're using a crane to lift up heavy blocks. And then, that does not look, so this is underground, but the one that I saw, they were stacking. But it's a similar idea, is you have a weight, a heavy vault, and so you use your excess electricity to lift that mass up in the air, and
there's one in there.
and you stack them, right? And then, so this is energy tower. This is sort of the idea. So you take these blocks and you stack them.
That's a lot of blocks.
And then you take when you need more energy, you have the crane come over and pick up a block, and then it switches so that it's motor. So almost all electric motors can easily be used sort of as a generator. I say easily. You can build it so that an electric motor, when it runs one way, is an electric motor. When it runs the opposite way, is a generator.
Huh.
And it's not a complicated sort of mechanical process.
It's not that hard.
And so that when you have extra electricity, you use the electric motor to lift these weights up to a height. And again, it's the same principle. When you elevate that mass, you're giving it potential energy. And then when you need more power, you use the crane to pick up a load and sort of lift it out. And then gravity is going to pull that down, and you just let it pull your weight down. And as it's pulling it down, it's running the motor backwards as a generator.
Do these things just fall, or do they try to...
Oh, I'm sure that they try to have them descend at a certain speed.
Like, I hope so, because otherwise it sounds like a problem.
Yeah, it's a disaster the other way, yes. So I'm sure there's going to be some kind of braking involved, and that's a potential inefficiency in the system. You're going to have it fall at a certain speed. Not just because your blocks will disintegrate when they hit the ground.
You could hurt somebody.
But
or break things.
All of these things, this is your electric grid runs on AC current. AC current has a frequency to it, just sort of like a radio wave.
Yeah.
Okay. The grid is designed to operate on a certain frequency. And one of the best ways to get the correct frequency is to manage the RPMs of your generator. And so they're going to want it to fall at a certain speed, not just to prevent damage when it hits the ground, but they're going to want that generator turning at a certain speed so that they get the correct frequency for the grid.
Well, yes.
So storage is a good idea. Energy storage is a useful thing. We don't have good storage solutions yet, but like it's a problem for these energy sources that rely on storage as compared to having storage be a bonus. Does that make sense?
Yeah. Like the storage kind of cancels out some of the pros.
Well, it's a necessity for wind and solar. You have to have storage to have a useful grid. If you had storage, then, so let's take the example of Texas again. Even if you had all of the power from gas or nuclear or something like that, not renewables weren't even part of the picture, that storage can be useful in the event of emergency. It can also be useful to help balance out the grid, and it may make it can make your prices cheaper because it makes it easier to manage if you have a little bit of that buffer instead of everything having to be matched up the whole time. So storage is useful, it just shouldn't be a necessity.
Oh, I get it.
The one of the main problems that I also have with wind power as a component of the grid, and in general, I think wind is a bad idea.
We see wind farms all the time.
Well, it's because they're subsidized. The government is giving them tax breaks and paying them money to build them.
Oh, okay.
So these wind turbines have a terrible lifespan. So solar panels, we're talking 20 to 30 years at least.
That's still a long time.
Gas-fired power plants, at least 20 to 30 years, probably more. There are nuclear power plants that their licenses were for 40 years.
Oh, dang.
They've been inspected, and if they got relicensed, they could run for another 40 years without changes or upgrades.
That's 80 years.
So, let's see if I can. So, I've been looking at. There's other resources. This is the only one I could find quickly. Wind turbines, the cost of them have been expected like 30 years or 20 to 25 years.
That's not horrible.
In reality, it's more like 15 years.
What?
Okay, so this is saying that gas hydroelectric plants can generate energy for more than 50 years.
That's a long time.
So 50 years. This, 15 years. And part of the problem is, so the components are pretty similar. You have a source of rotational energy, right?
Mm-hmm.
And you have like a shaft, and you might have to have gearing and stuff like that to get the appropriate speed, because the generator is going to work best at a certain speed, and it's going to want to match the frequency. So in something like a gas-fired plant or a nuclear plant or a hydroelectric plant, these are big parts. They're big, heavily manufactured pieces of equipment, right? In a wind turbine farm, that's up there on the top.
What?
It's small.
Why don't you just put it at the bottom?
Well, you want to have the shaft driving directly onto the generator. So the generator is up in the air. By necessity, it is small.
It's small.
And smaller parts just wear out quicker than bigger parts, because that mass of metal usually can just absorb more forces on it before it starts to deform, right?
That makes sense.
And so these big parts just don't wear out. They also
They do wear out eventually,
well, yes,
but it takes a long time.
They are concealed, and these are exposed.
Oh.
So the generator and the turbines and all the parts that I want to last for a long time in my power plant, like whether it's a nuclear power plant or a gas power plant, they're in a building somewhere, right? And there's stuff around it. It has protection.
Extra protection.
Yeah. Now, in some cases, may have more protection than others. Like we talked about, the gas-fired plants in Texas, because to dissipate heat, they were outside a lot, and that's one of the reasons why they froze up. But in these wind turbines, they are
literally in the sky.
yes, and so all of that heat, all of that cold, all of that moisture is just much more likely to have an effect on these smaller components that are up in the air and they're exposed outside all the time. They're also subject to more forces. So when I'm going to build one of these big power plants, right, I'm going to lay down a nice big concrete pad. I'm going to have it inside there. And whenever I turn it on and off, that's pretty much the limit of the forces that it's exposed to. When I have this generator up in the air, right, well, when the wind blows and changes directions, it's going to shake it, it's going to vibrate it, it's going to turn it around.
The greatest force, gravity.
Well, there's gravity tugging on it, so it's just exposed to more forces than these other components, because there's these huge components and they're concealed inside large structures. They're not as subject to sort of extraneous forces as these other wind turbine things. Like they're getting shaken whenever the wind changes, there's vibration, there's just a ton of problems that limits their lifespan. And so I think if you're going to make smart decisions, you're going to make one of two decisions. So if you're going to use solar, and I don't think it is again good for the grid, but it does have good applications. Like space stuff uses a lot of solar because it's outside the atmosphere where there's a lot of sunlight.
Oh, that's smart.
And it's not like we're going to run a power line to the moon.
Right? I don't think we can do that. That would be weird.
Yeah. The solar panels are also solid state, which means they don't have moving parts, right?
They just kind of sit there.
They just kind of sit there. And so that's one of the reasons they have a long lifespan, is because it's not like there's a motor or a bearing or something to wear out. So they have good applications. Remote applications where we need stuff off the grid, good. Applications where they're sort of what they call, I don't know if they call it energy, but in water they would call it point source, which means we're not getting it from another source and having it distributed through a distribution system. It's generated at the point where it's being used. I think that is a great application. So like I said, space, great application.
Probably is a bit more convenient in space.
Yes. So it has uses. The other choice you're going to make is you're going to want to make it where it's big, reliable parts.
You can also do that in space because, I mean, space.
Well, the reason you don't do that in space is because it costs to get those big, reliable parts up in the air.
Well, yeah, but you
So if you already had a factory in space, you'd have lots of room and not very much gravity.
International Space Factory.
So that brings up the question, like, what would be good choices for power if wind and solar are... So wind's a terrible idea, solar is a good idea for certain uses, not a good idea for grid. What kind of power sources are good choices? So, natural gas fired dual cycle plants. So dual cycle plant means you turn a turbine based on the actual burning of the natural gas, just like a jet engine, and then you harvest the heat to boil water to turn a second turbine. Incredibly efficient, makes good cheap energy, it makes fairly clean energy. It's one of the reasons why the United States has actually reduced its greenhouse gas emissions.
From fire?
Well, because that natural gas burns clean. And whenever you can harvest...
Oh yeah, it didn't have like smoke or anything.
Well, you can harvest the energy 2 times, and so that makes it very efficient.
Oh, that is cool.
That is a good source. But we'll pretend like we want something that is carbon neutral. Something that does not generate carbon.
You're thinking of nuclear.
I am thinking of nuclear power. So nuclear power is one of the good ones. We're going to talk about a couple of different ones.
Media makes it look so much freakier.
Yeah. So one of the things that you brought up, like, remember what one of the questions you asked whenever about nuclear power? What was it?
Well, I basically asked if it was safe because, like, it's always kind of depicted as being dangerous.
Well, you always ask about this thing. Let's make it more red. Pink would be too cute.
Pink would be too cute. Oh.
The mushroom cloud.
The explosions. That's
yes, if there's going to be an explosion. So, the way that nuclear reactors work, this is not a thing. It's never going to nuclear bomb explode. Okay? It is fairly safe and getting safer. So, they have generations of reactor. So, Chernobyl, which was like the famous, like one of the most famous disasters.
Yeah, everyone knows about that one.
That was like a Gen 2 reactor.
And didn't you say they were a corrupt government?
Oh, yes. They're Soviet government. They did terrible things. They were
it was
stupid.
a Soviet government?
Yes.
That kind of
Well, I mean, they're Russians. The Soviets, USSR, communists. They did. So we're up to like, I think we're doing research on Gen 4 reactor.
Oh, that's cool.
And some of the things they do is like, okay, so we have a nuclear reactor in here. Even though it's nuclear power, the principles are the same. Is we have these rods of a fissionable material, like uranium, and when they're in close proximity to each other, they give off neutrons and they cause a nuclear reaction, and they make a lot of heat. Yes, and then we, in time-honored tradition, we have coolant running through here. It's usually water.
Yeah,
right?
Those big water chambers, right?
Yeah. It makes steam, and the steam is what turns the turbine.
Yeah. Where is that one plant that we drive by sometimes?
There's one in Arkansas that we drive by when we go east.
Yeah.
And that's what these are. These are the big towers are cooling towers. They run the water up so it will condense out of steam back into water, and they run down. They also have these things called neutron absorbing rods, and it's these, or control rods. And they're made out of a material that will block the neutrons from causing a nuclear reaction. So to have a nuclear reaction, you've got a nucleus over here, and then it gives off a neutron, and when it smashes into one of the other ones, they split, right? And they give off more neutrons, and it goes and hits another one, right? It's literally a chain reaction.
Yep.
So if you have something that blocks the neutron right there so it can't go hit another atom, the reaction slows down. And so here's some of the things that they've done. So in some of the older plants, it required energy to pump the coolant through the system. And so if you had a power failure, like from a tsunami, Fukushima, then you couldn't pump coolant into the system, and it would overheat, and it would start. It either melts down, which is when the rods actually melt, and or it builds up pressure, and you get what's called a containment breach. It builds up pressure inside there, and so it cracks.
It just kind of starts leaking out.
Well, it's usually a gas gets blown out.
Oh, that's worse.
That's when you get so radioactive containment or contamination.
You would literally be breathing in radiation.
Well, these processes, since we've got superheated water, sometimes they make hydrogen.
Hydrogen?
Yes, because hydrogen, oxygen,
Oh,
H2O.
Yeah.
Hydrogen, kind of explosive, and so you get hydrogen explosions.
It is mildly explosive.
Yeah, and so you get, those are the sort of the things you get. Well, in a lot of the newer systems, this is actually fed by gravity.
What?
Yeah, so like you pump the water up into an elevated tank, and then gravity, that's the same way that you get your water, like to our house. You pump it up into a water tower, and the water pressure is what actually pushes it out to everyone.
Yeah.
So even if you cut off the power, there's still water pressure for a short amount of time.
Oh, that's smart.
So they started doing it that way. So even if you have a power failure or some kind of interrupt in the water system,
it'll keep cooling it down.
you can still keep running coolant through there for a certain amount of time.
Oh.
The other thing they've done is this system is also controlled by gravity, and what it does is the rods have to be lifted out with something under power. So like you've got a I don't know, like a pressure system or a magnetic system, something like that.
You could just use like a small crane.
We'll see, the small crane though, if you cut the power on it, the crane's going to stay in place the way it's built.
Oh.
The way these systems are designed is it requires energy to lift it out. And so if you have some kind of failure, all of these rods just slam down into the system and they basically shut down the reaction. The newer reactors are supposed to be even safe and safer. They have newer fuels with stuff called thorium. Some of the new reactors are considered to be meltdown proof.
I don't think it's going to be meltdown proof, but that sounds a lot safer than anything has ever described it.
Well, that we could spend we can do a whole video talking about them.
Yes.
The other thing people worry about is nuclear waste. So
the rods in the tank.
Yeah, when the rods get used up, you have to go and you have to store them somewhere. People get freaked out about it, but we've actually, like, all of the nuclear waste that has ever been generated can fit in a football stadium in the entire world.
That's a lot.
Well, but it's not much by comparison.
Okay,
so that's
by
all the waste
comparison to the world, fair enough.
And what they do with the rods is they encase them in a metal housing, and then they pour concrete around that metal housing. So the waste itself is not terribly dangerous after they've processed it. Mm-hmm. And the good news is there are some of the newer reactor designs. If we invested the money from it, they could actually reprocess the waste, and the products that came out would not be radioactive at all.
Why don't we do that?
Well, they haven't got the science quite figured out
Okay, we're gonna have to take some time on that then.
Yes.
All right, that would be
so.
Everyone would get peace of mind.
Yes. One of the other countries that has done really well with electricity, even though we make fun of them for surrendering all the time.
It's the French.
The French use a lot of nuclear power. So let's French power. Let's see, mix ratio. Let's see if we can get a nice graph.
Yes, we got a graph.
French energy mix. So,
this says energy consumption.
Where's nuclear? Oh, French energy by source. Nuclear, 71%.
That's a big number.
So,
a large percent.
If you compared France and Germany, so Germany went hardcore into the solar and wind. France has done a lot of nuclear. As far as I understand, neither one of them has really reduced their emissions as much as the United States has. But they've done better. France has done better in that regard. And the electricity in Germany, 5 times more expensive.
That sucks.
So your electric bill in Germany would be 5 times what it is in France because the nuclear power is cheaper, more efficient, stuff like that. So nuclear, yes, I would consider that a good choice. There's other good choices though. Can you think of one? Something that wouldn't produce carbon but is reliable.
Are you talking about natural gas or?
Well, natural gas could produce carbon.
Hydroelectric?
Hydroelectric is a good choice. So hydroelectric has been around for a long time. It is the largest source of non-carbon emitting power in the world. So of course hydroelectric, we have a big dam of some kind, blocks up a bunch of water. We let that water run through and it turns turbines. So there's lots of reasons to love hydroelectric. it's a big, clean energy source. Now, it takes some money to invest into it, but yeah, it's good. It can do a lot of work for our grid. One of the things that people don't like about hydroelectric, though, is they don't like dams. But we can fix a lot of problems with the dams. So one of the thing that, and this I think is only in the northwest United States.
Salmon ladders.
So one of the things is that whenever you build a dam, then it blocks sort of the upstream migration ability of certain fish, right? Because they swim upstream to spawn.
Yep.
And so one of the things that they do is they build these things called salmon ladders, which are basically little sort of bypasses with little hop steps so that the salmon can swim upstream and spawn.
So they make a sort of just a little tunnel, well, more of a ladder, I guess, for the salmon.
Well, it's stairs.
Sort of. Oh wait, there's one for eels too.
Yeah, so
Eels, gross,
the eels need to go upstream too,
Yeah,
and so they have these sort of little gateways. The ones that I've seen, they've sort of got little artificial grass that helps them.
I've seen here made of cups. It's got eels coming out of it.
Yeah. So they slither up these cups so that they can go upstream.
Eels aren't my
favorite.
favorite.
Oh, there's one. They got bristles.
Bristles.
So it's a climbing ladder or an eel ladder or eel gate.
Eels might not be my favorite animal, but yeah, they still need to spawn and stuff.
Yeah. So there are solutions to a lot of the problems with hydroelectric. If people would just get on board with it, let us build the dams, let us do the hydroelectric. Hydroelectric creates water reservoirs, which can also be useful for supplying drinking water and for doing flood control and things like that. So it's good stuff. There's also new designs that don't have any of the problems because they don't need dams.
Oh, that looks cool.
Now these are smaller, but it's basically, so you have a stream on this side. You can open up this gate and the water comes down and it's still using gravity. There's a turbine in there that basically creates a little whirlpool, and then this is fed right back into the stream where it came from.
Oh.
So I think in terminology wise, this is considered to be micro hydropower because they're not very big. So there's an example, right? You have you divert some of your water from your stream, you run it down this vortex to turn a turbine, and then the water's returned to the stream. Supposedly fish can go down through here.
I don't know about that.
And not get hurt. Well, that's what they say. I have not tested it out. This one has sort of a block though. The ones that the water may be able to flow over that. Because the ones that I've seen, the idea is that you're just diverting off part of the water. You're not blocking the stream at all. And you can have a series of them running. And so your fish can swim upstream, or your eels or whatever. There's no obstruction. They can come in and they can turn and do whatever. You have these hydroelectric systems. The other one is that dams block the movement of silt downstream.
What?
So silt is like dirt that's floating in the water. And so that can create problems. So you have to clean it out because it piles up at the foot of the dam. And it doesn't get downstream where other ecosystems can use it. In this case, the silt can freely flow downstream. So there are hydroelectric solutions that we should be considering because, again, if we're going to assume that we have to have zero carbon, and then this is a really good resource that we should be harnessing. Sort of related to that is tidal power. Tidal power works sort of on the same idea, except instead of using like a river, you're using the water flowing in and out of an area based on tides. So how many tides are there a day?
Dang it. I don't know.
There's 4. 2 high tides and 2 low tides every single day.
There's only 2. Okay.
So, there's only a couple of these built, but this is called a tidal barrage. And basically, you're building something that's kind of like a dam.
It's kind of like a bridge.
Well, yeah. And so what happens is when the tide starts coming in this area, you shut it all off so that this area gets lower and this area stays higher. And then whenever the difference is enough, you release the water to go through, and it turns some turbines, similar to a hydroelectric dam, and generates electricity. Well, then, eventually, when the tide shifts, it's going to go out this way, and you do the same thing. You block the water up till this side gets high, and this side gets low, and then you release it so that the water can go through and turn a turbine and create power. People don't really like these because it is a big investment and it has a lot of the same problems with dams. It's blocking off the wildlife, you're sort of changing the way the silt moves, and there's not very many of them that have been built. I think there's only like 2 or 3 in the world. But there are, oops, spelled it wrong, but I'm sure.
Ruben.
This idea where you can put these turbines down on the seafloor, and it does the same thing. It's like a wind turbine, except instead of being at the mercy of the wind, you've got 4 tides every day. As long as the moon and the earth are still in their orbit, then the tides are going to move 4 times a day.
Well, you're also at the mercy of the ocean now.
Yeah, so it's more efficient than wind. For one thing, water's thicker, and so it's got more energy, and it's more reliable because, like I said, there's 4 tides every day, as long as the moon circles the earth.
Well, I hope the moon doesn't stop, because that might be a problem.
Yes. So, tidal power, also another good idea. They've been doing research on these turbines, and it's possible to use fencing and some little sonic warning things so that wildlife doesn't get caught in them. If we move to those, that would be a good idea. Now, because the tides are only 4 times a day, these are going to be a little bit more reliant on storage, but it's probably better than wind. One of my favorites is, we've got hydroelectric power, we've got tidal power, we talk about nuclear power. One of my favorites is another kind of power, and it is still based on the idea that you're boiling steam or boiling water to create steam to turn a turbine, but we get the heat from someplace else.
The ground?
Geothermal.
My brain died for a sec.
So traditionally, geothermal power is pretty easy to understand, right? So as you go down, the earth is hot. There's heat inside the earth. Some of it's leftover heat from the formation of the earth. Some of it is just from gravity, just all of the rock, just weight crushing down on stuff. Some of it's from radioactive isotopes decaying. So when it decays, they're giving off energy, it gets turned into heat. And Earth is a pretty good insulator, and so that heat stays trapped down in there. But so there's heat on the inside of the Earth. And if you have water in there somewhere, so like in places where it's close, you get like Old Faithful, you get a geyser, right? That's boiling water that has been heated up by a geothermal source. What we can do is we can build a power plant, right? We can build a power plant here, and we basically have tubes that we run down here. They get heated up. They come back up. That superheated water, we allow it to evaporate as steam, and it turns a turbine, which creates electricity. And in this case, you can have what they call open loop or closed loop. Is you can just have water that you pump down in here. It gets heated up. When it comes back off, you let the steam escape, and you just keep bringing in more water. Or you have some kind of cooling tower or heat exchanger that cools the water back down. That would be a closed loop. And then so you're just pumping the same water over and over and over again. that's traditionally what has been done with geothermal energy. Is you have places where you got hot rocks, basically, where geothermal energy is close to the surface. But there is new technology, and I love it. I think it would be good. I think it would be good for Oklahoma specifically. So binary cycle geothermal. Because there's a limited number of places where, let's see if this is, yeah. There's a limited number of places where you have the, where your geothermal energy is hot enough and it's close enough to the surface where you can run the kind of plant I described at first. In this one, we're still going to pump hot water down, or we're going to pump cold water down, and it's going to be heated up by the earth, and we're going to get hot water up. But instead of evaporating that water, we're going to use a working fluid. So a working fluid is a type of fluid that's going to evaporate at a lower temperature than water. And so this is similar to like how our modern air conditioning works.
Oh.
So there is a chemical in our lines, and actually at room temperature and room pressure, I'm pretty sure it's a gas. But you compress it and it turns into a liquid. You pipe it through, and then whenever you let it evaporate, it soaks up all the heat. And then so you can then move that gas to another location, and when you compress it, it dumps all the heat out, and that allows you to move heat from one location to another. So in our particular case, we move the heat from out inside the house to the outside, right? In this case, you've got a working fluid. You're going to pass it through this area, and it's going to absorb the heat, and probably you're going to keep it compressed until it gets here. Whenever it goes and it has lower pressure, then it's going to evaporate. It's going to turn into a gas, and that gas is going to turn the turbines, and it's going to spin an electrical generator. Pretty much the same principle that we've been talking about with almost all of these sources. Like, there's just a ton of ways that humans try to get steam of some kind to turn a generator, or water to turn a generator, right?
Yeah. Well, steam is kind of like a form of water.
Yeah. So same basic principles, but we're using, hot water out of the ground to heat up a fluid that's going to evaporate at a lower temperature, and using that to turn the turbine. One of the reasons I think this would be great for Oklahoma is one of the ways that they are doing experiments with building these geothermal plants is, so they have ground, and we have a geothermal source down in this area. It's, we think it can make warm water but not hot water. To increase its capacity, they're injecting water down into these formations under pressure so that it creates fractures and there's more volume for the water to go into. Does that sound in any way familiar? We live in a county with lots of oil and gas, right? You've heard of fracking, right?
Kinda.
Yeah, it's the same idea. So you have these rock formations. They're going to pump water down into there, crack it open, and so that there's more volume, and then pump out the hot water, and then you can use that to heat up your your working fluid in a binary cycle geothermal plant.
It does kind of remind me of oil.
Well, so our county in specific has lots of oil and natural gas work in it.
Yep.
If you talk to people, most people don't know it, but a lot of times their fracked wells, they get hot water out of them.
Really?
Because, they're deep enough and they have enough exposure that they create, it's not like boiling steam geyser type water, but it is hot water. And so we already have a location where there's lots of potential wells that could be used to bring up this we'll call it warm water, or we'll call it hot water, but it's not super hot water. It's not like
It's like kind of hot water you get out of your faucet.
it may be even hotter than that.
Maybe hotter than that, but still.
But it's not like we're gonna
scald your skin hot.
we're not gonna get like a steam geyser out of them
No.
like Old Faithful, but it should be hot enough to run one of these binary cycle generators, and that to me is the perfect idea for a place like this. Is we already have these wells, we already have the expertise on how to manage them, how to frack them. Let's put these systems in place, and then you would have clean, efficient, cheap, zero carbon energy, and you would also be taking advantage of sort of the oil and gas work that's already being done. It can sort of do double duty.
Huh.
Yeah. So let's see. So heat. Let's go average heat water from fracked well. Let's see if there's actually a number. But they do make hot water.
Oh, we got a chart.
Yeah. I have no idea because like there's a lot of pump system, temperature of wells. So it's getting up pretty hot.
Oh, that is. Oh my gosh. Maybe I was wrong. That could burn your skin.
Yeah, I don't know.
Do they got a number?
So there's, yeah. So they're talking about how much water that they use, but they don't really talk about the temperature of the water coming out. But to me, that is an excellent solution. So if I were going to be in charge of the energy policy of the country, here's what I would do. There would be no wind power.
You know no one's going to go for that.
But, I mean, like if somebody wants to build wind power, that's fine. But to me, there would be no incentives for wind power. It's a terrible idea.
Okay.
Solar power in certain instances.
But it wouldn't be connected to the grid.
It would not be grid power. It would be off-grid power. It would be emergency power, things like that. The stuff that we would absolutely do and that we would encourage, nuclear power.
Yep.
The little radiation trefoil. Nuclear power, hydroelectric power. Oh, that's terrible.
That's weird.
Tidal power, which will put waves and have a little guy. Tidal power. And geothermal power, especially binary cycle geothermal power. And with all of those, you could supply 100% of our energy needs. It would be clean, it would be efficient, it would be zero carbon if that's important to you. I'm not saying that it's super important to me, and you'd be able to have cheap, reliable, which I think is one of the most important things. These tend to not be very reliable. These over here are reliable. Clean, efficient, reliable, and inexpensive energy sources. So that's, if you gave me in control of all of our energy policy, that's the direction we would go.
Well, no one's going to go in this direction.
Well, that's because no one is as smart as I am. That's not true. There are people that are smart. They've talked about it. There's a guy he pushes. He likes to call it the green nuclear deal. That we should go heavy into nuclear energy. There's also a guy named Michael Schellenberger.
Schellenberger?
Yeah, he is an environmental activist. Like, he actually helped found environmental groups, and he is big in favor of things like nuclear energy and nuclear energy for sure. I think I've had him talk about, or seen him talk about, geothermal before, but he says, like, in reality, those are the best things for the environment, is if we went that way.
Okay, so people are this smart, but not all people.
Just not enough people in government are that smart.
Okay.
One of the things that he talks about, though, specifically, is that One of the reasons why wind and solar are a bad choice is that they were never intended to power a high energy modern society. A lot of the people that heavily promoted wind and solar, if you read sort of their philosophy, and he has some guys that he mentions. So, like, anyway, like a lot of the people that really promoted, so Martin Heidegger is one of the guys that he's talked about, and this dude named Murray.
Murray?
Yeah.
Uh-huh.
But basically, their idea was they wanted to heavily promote wind and solar power, not because they wanted to have a modern high energy society like we have, like where we produce and consume lots of energy to create comfort and wealth and things like that. They didn't want that. They wanted wind and solar specifically because they could not do that. They wanted wind and solar because they wanted humanity to return to sort of a pastoral agrarian lifestyle where everybody kind of had their own little plot of farming, and we didn't have big cities and jets, and we didn't have an internet and all these sort of high energy intensive things. They wanted to move away from that kind of society. So that's one of his arguments for why we shouldn't, why we should not be relying on wind and solar, is because they never were intended to support the kind of society that we're trying to create. They were the people that supported those sources of energy supported them specifically because they would force us to return to a more primitive, rural, agrarian type of life.
Not exactly primitive, but we do kind of live in a rural area.
Well, I mean, we're in a rural area, but we still have a lot of modern comforts. We have our life right now is substantially more comfortable and more energy intensive and more productive. I mean, I can do computer programming jobs from anywhere in the world because of the internet. That did not exist even when I was in high school. And so, like, it is an incredibly beneficial thing to have these high energy societies. That's one of the ways that you lift people out of poverty. It's one of the ways that you create greater health because you can devote more energy to things like healthcare and preventative medicine and things like that. It's how you create wealth. You have all of this energy that you can use to create new products. And again, so if you read this guy, Schellenberger, one of the things he says is a terrible thing that we've done is because we've been fascinated with wind and solar, we're trying to force those ideas onto developing countries in like Africa and parts of Southeast Asia.
Dude, what they're doing is not exactly our business.
Well, that's true, but he's saying like a lot of these development organizations are trying to get those countries to skip fossil fuels and just develop wind and solar, and the problem is they're too expensive and they're not efficient enough, and so these communities are struggling to move out of real poverty. I mean, it's hard to imagine, but there's places in this world where to cook a fire or to heat your home, like your little hut, they burn dried cow dung and things like that to make their cook fire.
That's a little gross.
And so, yeah, it is a very low energy, impoverished kind of society, and they would benefit greatly if they had strong, efficient, reliable, cheap sources of energy. And yeah, if they can skip the fossil fuel step, that's probably a good idea. I think we'll use fossil fuels for a long time, but we have lots of different uses for them. And so if they want to skip that fossil fuel step, that's fine. They should skip to nuclear power, hydroelectric power, tidal power, geothermal power, and limited uses of solar power. But a lot of these organizations are trying to force wind and solar on these impoverished countries, and it's actually making it harder for them to develop their country out of poverty because those sources are just not built to sustain or build a high energy, productive modern society. Have any questions?
Nope.
No? Alright. So what do we tell everybody at the end?
Like and subscribe.
Like and subscribe. Good job.